Okay, here is an example concerning the parallel and the series connection of resistors. And here is the example. Three resistors R1 equal to 6 ohms, R2 3 ohms, R3 2 ohms are connected in parallel through a voltage source of 12 volts. Find the equivalent resistance. That is 1, 2. The total current, 3. The current through each resistor. So we can sketch this problem. Resistors are connected in parallel. I will say that R1 is 6 ohms. This R1, 6 ohms. R2 is 3 ohms. And R3, this R2, R3 is 2 ohms. And the voltage source is 12 volts. This is a rough sketch of what we are talking about. And this is the direction of the current. Current moving in this direction. I will have 3 questions here to answer. Find the equivalent resistance, that's the total resistance. And in our previous class, we talked about the formula to calculate the equivalent resistance when they are connected in series, when they are connected in parallel. I will say that for parallel connection, we have 1 all over R equal to, that is equivalent, 1 all over R1 plus 1 over R2 plus 1 all over R3, since there are 3 resistors. If they are 10, it will be up to R10. If they are 2, up to R2. If they are 4, R4. So we now substitute these values here. 1 all over R equivalent means 1 all over 6 plus 1 over 3 plus 1 all over what? 2. So if you have something like this, you need to take the LCM. And the LCM of 6, 3, and 2 is 6. So it says 2 into 6 is 3 times 1 is 3 plus 3 into 6 is 2 times 1 is 2 plus 6 into 6 is 1 times 1 is 1. So if you add up this, 1 plus 3 is 3 plus 3 is 6. So we have 6 all over what? 6. So we can now say that we can now say that 1 all over R is equal to, that is R equivalent, is equal to 6 over 6, which is equal to 1. And we can say that R equivalent is equal to 1 ohm. Then the second question is the total current. Since we have calculated the equivalent, the total resistance from Ohm's law, we can say that V is equal to IR, and I, that stands for current, will be equal to V all over R. And the voltage source is 12. And the R is what? The R we have calculated is 1, the total distance. So this will be equal to 12 all over 1, which will be equal to 12 ampere. Don't forget to write down the unit. So the next thing we'll do is we'll calculate the last question, total current through each resistor. Total current through each resistor. Like I said earlier, the current through, if they are connected in parallel, the current through resistor 1 is different. Maybe this is I1, this is I2, this is I3. So from here, the same Ohm's law, we can say that V is equal to IR, and I is equal to V all over R. That's the current through each resistor. And in this case, the potential difference is common, which will still be 12. And this will be equal to 12 all over for R1. This is 6 because R1 is 6, and that will give us 2 amps. 12 divided by 6 is 2 amps. Then for the second one, for the second resistor, we'll now say that this is I1, I2 now will be equal to V all over R2, which will be equal to, for V is still 12, R2 is 3. So 12 divided by 3 is what? 4 ampere. Then for I3, we have V all over R3, which will be equal to 12 divided by 2. 12 divided by 2 is 6 amp. So this is the current passing through each of these. So the implication here is that when you have a higher resistor or the resistance, the smaller the current. For where we have 6 ohms, we have 2 ampere. Where we have 3 ohms, we have 4 ampere. Where we have 2 ohms, the current increases. That verifies the statement of Ohm's law that current is equal to V all over R. It means that the higher the resistance, the lower the current. And the lower the resistance, the higher the current. And that's what makes a good conductor. Thank you.